In my project, I will be teaching how to solve problems with fractional and negative exponents. This topic will cover everything from square roots to cube roots and fourth roots, and explain how to not only add and subtract radicals, but multiply and divide them as well. All of these ideas build off of each other, and you will see that in the end, you will be able to do problems that include many of these ideas in one question. We'll begin by explaining what fractional and negative exponents signify. For positive exponents, you just multiply the number by itself as many times as the exponent says. So, for example, if you had x to the third, that would just be x times x times x. And if you had 3 to the third, it would also just be 3 times 3 times 3. Or there may be situations like this, in which case you do the same thing. So if you had 1 over x to the negative third, that would just be x to the third. And if you had 1 over 3 to the negative third, that would just be 3 to the third, which we all know would be 3 times 3 times 3. Once you flip the expression, it is as if the negative in the exponent disappears and the expression now is positive. So now you try it. 1 over 4 to the second would just be 1 over 16. And 4 to the negative 2 would just be 1 over 4 to the second, and that is, again, 1 over 16. Next, I will explain how to simplify equations with fractional and negative exponents. When you have a fractional exponent, you want to. So if you had x to the a over b, for the numerator, which in this case is a, you want to raise the base to the 8th power. And for the denominator of the fraction, which in this case would be b, you want to take the bth root of the base. So this would be b rad x to the a. It is helpful to bth the root of the base first and then raise the base to the 8th power. Also, you can determine the value of a number with a fractional exponent or any exponent by merely plugging it into your calculator. For example, if you were given 3 to the 1/2, all you have to do is plug that into your calculator. And, well, you should always plug it in 3 that and then parentheses 1, 2, but then you should just get the answer. And all you need to do, and if your answer is in decimal, all you need to do is press math, enter, fraction, enter, and your answer will appear as a fraction. Well, let's say we didn't have a calculator and we had to use our brains, then let's try it. So if you had 4 to the 3 over 2, you would get rad with a 2 in the index, 4 to the third. First, you square root the 4, which would equal 2. So that would be 2 third. And then you raise it to the 3rd power. So that would equal 8. And there's your answer. And let's take another example. So 27th raised to the power of 2 over 3 would just be rad with 3 in the index, 27 raised to the power of 2. And that would just equal 3 raised to the power of 2, which ultimately equals 9. And for simplifying negative exponents, it's basically the same steps, only you must first apply what you first learned about negative exponents, which is that you must flip the expression before solving. So for example, if you had 1 over 4 to the negative 1/2 raised to the power of, sorry I didn't make that so small, you just flip the equation so that it's 4 4 to the raised to the power of 1/2. And then you apply exactly what you did for simplifying positive fractional exponents. So this would just be rad with 2 in the index, and then 4 raised to the power of 1, and this would just equal 2. So now you try it. So if we had 125 raised to the power of -2/3, that would just turn into 1/125 raised to the power of 2 to the 3, which would ultimately just be 1 rad with 3 in the index, with 125 raised to the power of 2 in it. So that would ultimately give you 1/25. Before I explain how to add, subtract, multiply, and divide expressions, I will first explain how to simplify expressions in 3 easy steps. First, step 1, is to see if any perfect square factor or any perfect cube root, 4th root, or 5th root, etc. goes into the radicand. Step 2, if it does have a perfect square factor or cube, 4th root, 5th root, etc., write the original radicand as a product of its perfect square and the other factor it would need to equal the original number that was under the radicand. One of the numbers must be a perfect square factor. Step 3. Square root what you can and repeat if necessary. So let's practice. So if you had rad 27, you would turn this into rad 9 and rad 3, which would soon become 3 rad 3. And if you had rad 98, that would become rad 49 and rad 2, which would just become 7 rad 2. Next, I will explain how to add and subtract expressions. For square roots, you can only add and subtract like radicals with the same radicand. So first, you simplify, and then second, you add or subtract coefficients of the radicand, and third, you keep the radicand the same. So, for example, if you had 2 rad 5, that should be a 5, plus 3 rad 5, that would equal 5 rad 5. And for higher index roots, it's the same thing. So if you had 3 in the index with 8 under the radicand, plus 3 in the index with 64, this would just be, after you simplify the radicands, it would just be 2 plus 4, which would equal 6. First, you simplify the radicals, and then you add or subtract the two numbers together. So again, if you had 4 in the index and 16 in the radical, plus 4 in the index and 81 in the radical, all you have to do is simplify the radicals and then add or subtract the two numbers together. So this would just be 2 plus 3, which will equal 5. So let's add everything that we've learned together by practicing adding and subtracting. So if you had 6 before the radical, and you had 4 in the index, and then 32 under the radical, plus 5, 4th root of 16, 162. All you have to do is break up the radicand, so this is how you're simplifying it, so it becomes 6 rad 16 with 4 in the index, and then rad 2 with 4 in the index, plus 5 with 4 in the index, rad 81, and then rad 2 with 4 in the index. And that ultimately becomes, because after we simplify it, that becomes 6 times 2, and then rad 4 in the index with 2 under, and plus 5 times 3, and then again with rad 2 with 4 in the index. So that ultimately gives you 12 rad 2 plus 15 2, both with 4 in the index. And that will ultimately give you 27 rad 2 with 4 in the index. I just don't have any room. And same exact thing goes for subtraction. So if we literally took the same exact problem, but we switched this to a subtraction sign, you would do the same exact steps. You would first simplify the radicals. So this would become, again, you would drop down the 6, and this would be rad 16 and rad 2 with 4 in the index minus 5 with rad 81 and rad 2 with, again, 4 in the indexes. And this would simplify to 6 times 2 and rad 2 with 4 in the index minus 5 times 3 with rad 2 with 4 in the index, and that would just become 12 rad 2 with 4 in the index minus 5 rad 2 with 4 in the index, and that would ultimately give you 3 rad 2 with 4 in the index. Don't forget to keep that 4 in there. And because it's 12 minus 15, that would ultimately give you 3 rad 2, but negative 3 rad 2. Okay, now let's try adding and subtracting in one problem. So if you had 3 rad 16 with 3 in the index minus 9 rad 2 with 3 in the index plus 5 rad 27 with 3 in the index. All the indexes have to be the same or else you can't add or subtract them. Point from before, just reminding you guys. So that would turn into, if you simplified it, that would turn into 3 rad 8. These all have 3 in the indexes, by the way. And then rad 2 minus 9 rad 2 plus 5 times 3, because 5 with 3 in the index. Our first step here is to simplify. So this becomes 3 rad 8 and then rad 2 minus 9 rad 2 plus 5, and that becomes a 3. So it's just 5 times 3. And all these, by the way, have 3 in the index. So then this simplifies to 3 times 2. Well, it simplifies to 2, so it becomes 3 times 2. And then that stays as rad 2 minus 9, and then rad 2 plus 5 times 3. And that becomes 6 rad 2 minus 9 rad 2 plus 15. And the answer will ultimately be negative 3 rad 2 with, of course, 3 in the index plus 15. And the reason that you don't add the 15 and the negative 3 is because you can't add unlike terms. So this just remains, and this is the full answer to the question. Next, I will explain how to multiply radicals. So your first step is to multiply coefficient by coefficient. Your second step is to multiply radicands by radicands. And your third step is to simplify as much as possible. So let's try an example. Okay, so let's say you had rad 3 with 3 in the index times rad 2 with 3 in the index. That would just be, this is a 3 in the index, 3 times 2, and that would just be rad 6 with 3 in the index. So in this case, there was no coefficients, but if there were, all you would need to do is multiply them. But let's say you did have coefficients. So let's say you had 5 rad 24 times 3 rad 10. So first what you would do is multiply the coefficients, so that's 15, and then multiply these two together, so that's 240. And that is your answer. Okay, so if you have this problem, 5 rad 24 times 3 rad 10, all you would do is 5 times 3, which is 15, and then 24 times 10, which is 240. But you're not done. You have to simplify this expression. So basically what you would do is you would do 15 and split this into 16 and 15. This would ultimately become 15 times 4 rad 15. This would ultimately be 60 rad 15. So now let's do some examples. So if we had rad 4 times rad 4 with 4 in the index, we would just do 4 times 4, and that would give us rad 16 with 4 in the index, and that would ultimately equal 2. And then for this problem, you would do the same thing, but you would have to distribute first, just like we do throughout all math. So you would distribute, and then you would ultimately get 9 rad 4 with 3 in the index, that's a 4, plus 3 rad 8 with 3 in the index, and that would ultimately be, once you simplify, 9 rad 4 with 3 in the index plus 3 times 2, because that becomes a 2. And that will ultimately give you 9 rad 4 with 3 in the index plus 6. And you can't combine them because they are unlike terms, so you just leave this as the problem. Next, I will explain how to divide radicals. So again, in 3 steps, I'll first say how you would do it. So first step, you would divide coefficients by coefficients. The second step, you would divide radicands by radicands. And the third step, you would simplify as much as possible. And sometimes there is a fourth step. So if the denominator is irrational, meaning it has a radical component, you must rationalize the denominator. Let's first try one without that fourth step. So if you just had 5 divided by 27, rad 5 divided by 27 with 3 in the index, that would equal rad 5 over rad 27, both with 3 in the indexes, and you would simplify. So that would become rad 5, because you can't simplify that anymore, over 3, because you simplified rad 27 with 3 in the index to 3. That would be your answer. But if there is a radical on the bottom, you must rationalize denominators. Rationalizing denominators is if the denominator is under a radical, then it is not considered in its simplest form. Therefore, you must rationalize the denominator by multiplying by. So if it is monomial, what you need to do is make the radicand a perfect square or a cube, etc., over itself. And if it is a binomial, the conjugate on both the numerator and the denominator will equal the conjugate of a plus b rad c. So that will be equal to a minus b rad c. So, for example, if we had 1 over 2 rad 3 times 2 plus rad 3 over 2 plus rad 3, that would ultimately give you 2 plus rad 3, and then this long equation, 4 plus 2 rad 3 minus 2 rad 3 minus 3. But because these are plus minus and they're the same, these will just cancel. And that'll give you ultimately 2 plus rad 3 over 1, which ultimately just gives you 2 plus rad 3. Okay, so let's try another example of rationalizing denominators. So if you had 4 over rad 8 with 4 in the index, you would first have to simplify the rad 8 with 4 in the index, and then set the answer as the numerator and the denominator and multiply the original expression. So here you see that it's rad 2 over rad 2 with 4 in the indexes, because that is what this simplifies to. And that ultimately becomes, once you multiply it out, that becomes 4 rad 2 with 4 in the index, and then over rad 16 with 4 in the index, and if you keep simplifying, that becomes 4 rad 2, and then over 2, and that ultimately becomes 2 rad 2 with 4 in the index. There's a 4 in the index here. It stays there. Just forgot it there. But that is how you rationalize a denominator, and that would be your simplest form of your answer. Lastly, I will put everything together by solving problems with fractional exponents. So this is an example of a problem that combines all that we learned in this lesson together. So we have 2 rad with 3x plus 1 in it, minus 8 equals 12. So the first thing you do is you add 8 to both sides, and that will ultimately give you 2 rad with 3x plus 1 equals 20. The next thing you do is you divide by 2 on both sides, and that will ultimately give you rad 3x plus 1 equals 10. And in order to, for the next step, get rid of the radical, you have to raise both sides to the power of 2. So we raise both sides to the power of 2 on both sides. The radical drops out, and that ultimately becomes 3x plus 1 equals 100. And then what you do, this isn't shown because there isn't enough room, but you subtract 1 from both sides, so that will ultimately give you 3x equals 99, and then you divide by 3 to get rid of the 3, and you divide by 3, and then x will ultimately equal 33. Okay, so now let's try another problem. So let's say you had 2x to the third equals 162. Your first step would be to divide by 2 on both sides, and then these 2's will cancel out, and you'll just get x to the third equals 81, because 162 divided by 2 is 81. And then you would find the cube root of 81, because you have to get rid of the x to the 3. So you find the cube root of 81, and as we learned in the simplifying part of this lesson, it would be rad 27 and rad 3, and that would ultimately simplify to 3 rad 3 with a 3 in the index. For our last example, we have 2x to the 3 over 2 plus 1 equals 17. So your first step is to subtract 1 from each side, and that would give you 2x to the 3 over 2 equals 16. Your next step is to divide by 2 on both sides. So you divide by 2 on both sides, and that will give you x to the 3 over 2, because the 2's cancel out, equals 8. Then what you have to do is raise each side by the reciprocal of the 3 over 2 power. So you see that x to the 3 over 2 equals 8, so that will be x to the 3 over 2 times its reciprocal 2 over 3, and whatever you do to this side, you have to do that side, so 8 times 2 over 3. This will ultimately become, because these cancel out, this will become x equals rad 8 to the 2, with 3 in the index, because this is how you simplify this. We discussed that in an earlier lesson. And this will ultimately equal x equals 2 squared, and that will equal 4 as your final answer.